Welcome to The Explainer. Today, we're taking a deep dive to demystify the web. I mean, we use it literally every single day, right? Clicking links, streaming shows, totally second nature. But how does an email actually get from your laptop to a server on the completely other side of the planet? We're going to travel from the physical, local hardware sitting right in your room all the way up to the massive, invisible architecture of the global internet. It's going to be a really fun trip. Now, before we get totally buried in the technical jargon of cables, routers, and code, let's look at this quote from Noam Chomsky. It's a great reminder to set a human tone for our exploration, because at its absolute core, before anything else, networks are fundamentally about connecting people and society. All of this incredible technology, it was built to share information, to organize, and to educate. Keep that in the back of your mind as we figure out how the machines actually pull this whole thing off. Okay, let's dive into this. Here's our roadmap for today. First, the power of networks. Second, hardware, connecting the dots. Third, topologies, shaping the network. Fourth, the global internet. Fifth, static versus dynamic pages. And finally, number 6, browsers and cookies.
Number 1, the power of networks.
So let's start right at the foundation. A computer network is basically just an interconnection among 2 or more computing devices, allowing them to share data and resources. In the networking world, we actually call every device connected to this network a node. So your laptop is a node, your smartphone is a node, even that smart printer in the corner is a node. Now, these nodes don't just blast massive files to each other all at once. For communication to actually work, data in a network is chopped up into smaller, manageable chunks called packets. Think of them like tiny digital envelopes being passed back and forth.
Number 2, hardware, connecting the dots.
Now that we know what a network is fundamentally, what are the actual physical boxes and blinking lights making it happen? Well, back in the early days, we used something called a hub. And honestly, a hub is pretty noisy. It's kind of like that one annoying coworker who uses a megaphone in a quiet office. When a hub receives data, it just blasts it out to every single connected device, which, as you can imagine, risks a ton of data collisions. But today, we use a much smarter device, the switch. A switch actually extracts the destination address from the data packet and looks it up. It acts like a highly efficient mail sorter, sending signals only to the specifically selected devices. And this brilliantly illustrates exactly what we're talking about. Look at all those Ethernet cables plugged directly into the various ports of the network switch. This single piece of hardware is the beating heart of a local area network, or LAN. It's what ties all those local nodes together in one room or office building so they can seamlessly share resources without constantly shouting over one another. Okay, so you have your local network connected by a switch, but how does it talk to the outside world? Enter the router. Yep, that's that dusty box with the antennas sitting in your living room right now. Compared to a basic switch, a router has some seriously advanced capabilities. It can receive data, analyze it, and transmit it to completely different types of networks. If an external network can't handle big data packets, the router will actually repackage your data into smaller packets before sending it on its way. It is literally the vital bridge connecting your local area network to the wider internet. And often working hand in hand with your router is the gateway. You can think of the gateway as the ultimate border control point. It's exactly what it sounds like, an entry and exit gate between an internal network and the outside internet. Every single piece of data coming in or going out of your network absolutely must pass through this gate. It acts like a super smart digital air traffic controller, making sure your data packet finds the absolute best possible route to its foreign destination.
Moving on to number 3, topologies, shaping the network.
We've seen the hardware devices, but how do we physically map them all out? That brings us to network architecture, or topologies. Common network topologies include mesh, ring, bus, star, and tree. Just like a city planner decides how to lay out roads to manage traffic, network engineers have to choose how to wire these digital roads. And there's a stark contrast in design philosophy here. Take a look at the mesh topology. Every single node connects to every other node. It handles high traffic beautifully, and if one cable breaks, the network survives. It's highly reliable and very secure. On the flip side, we have the bus topology. It relies on a single shared backbone wire. Sure, it's way cheaper and easier to set up, but if that main bus line goes down, well, the whole network stops dead. It's your classic trade-off between cost and reliability. Number 4, the global internet. Let's zoom out now. We've built our local networks and wired them up, so let's look at the macro scale. The internet isn't just some magical cloud. It's simply a global interconnection of millions of computing devices. It's millions of those smaller local area networks hooked up together. And today, we're not just talking about desktop computers and massive servers. It includes smart appliances, your smart TV, your air conditioner, drones, security cameras, even your door locks. This absolutely massive web of interconnected devices is what forms the internet as we know it. Number 5, static versus dynamic pages. Now that the physical roads are built, let's talk about the digital traffic flowing across them, web pages. When you visit a website, you're looking at either a static or dynamic web page. A static page is unchanging. It's delivered as is by the server. It's essentially a read-only document, kind of like a digital brochure. It looks exactly the same for every single user. But a dynamic page? That is where the modern web actually lives. That's your personalized social media feed or your online banking dashboard. Dynamic pages are interactive and customized via scripts, like JavaScript, which dictate how the page behaves based on what you specifically do. The magic of navigating these pages happens in a constant, lightning-fast conversation. Step 1. Your web browser sends an HTTP request asking for a specific page. The server processes this request, maybe it runs a script or checks a database, and then step 2, it sends an HTTP response right back. This response contains the code that your browser turns into the page you actually see. It's just a relentless game of digital ping pong happening in milliseconds. But where do all these web pages actually live? Well, they live on physical servers, which brings us to web hosting. If you build a website, you need a place to put your files so the world can access them. Web hosting is basically renting server resources, things like CPU power, RAM, and storage, to make those files accessible globally. You upload your HTML and CSS to their connected servers, and suddenly your localized creation is out there for the whole world to see. Finally, number 6, browsers and cookies. Let's bring it all back to the software that you interact with every single day on your screen. You know the names: Google Chrome, Safari, Firefox. But what is a browser, really? It's a software application that retrieves and displays HTML documents from various web servers. Think of it as your digital translator. It takes all those retrieved packets of raw data and invisible code, and it translates them into the beautiful text, images, videos, and clickable links that you actually experience. So here's a question. How do websites actually remember who you are? They do it through cookies. A cookie is basically a text file transferred by a website to your browser to recognize you and store your preferences. These are the quiet memory banks of the internet. They're the reason your language choices are saved, why your items stay in your shopping cart, and how you can auto-log in to your favorite sites without ripping your hair out typing your password every single time. We've traveled from the concept of a simple, local connection all the way to the vast expanse of the global internet. So I want to leave you with this final thought. Look around your room right now. Think about your smart TVs, your AC, your smart locks. How many nodes are quietly communicating in your house right at this very second? It's pretty wild to think about, right? The invisible journey of connection is happening all around you, constantly. Thanks for joining me on this explainer, and keep that curiosity alive.